All right, you asked for it, so you've got it. The long-awaited section on polar. So the first little section here is just going to be an intro to polar, so no calculus yet. We're just going to go, what is polar coordinates, what are polar coordinates, how to convert between polar and rectangular coordinates, and how to graph in polar coordinates. All right, so first up, polar coordinates are not x and y, so we're not doing the rectangular coordinates anymore, but they are r and theta. It's a radius, it's a distance out from the origin, or the center, and it's an angle of what angle you're going to go out that far. All right, so theta is our angle in the unit circle, r is how far we go out. So this is a picture of polar graph paper right here. So this is polar graph paper. All right, you don't necessarily need polar graph paper to draw polar, but usually you make a bunch of circles out from the center, like grading out from the center, and then you can draw angles on there. You don't necessarily have to draw the angles. Sometimes I just draw the x and y axis and then just use what's in between there. So here's an example of a polar point. So this is r is 2 and pi over 2 is our theta. I usually go the angle first. So I start with the second coordinate, the theta coordinate, and I say, okay, I want to go to pi over 2. So pi over 2 is right here. So I'm on basically the y-axis. And then my radius is 2, so I want to go out 2 from the center. So 1, 2. So there is my point, 2 pi over 2. All right, I'll try and do each one in a different color here. So for the next one, we've got 3 for a radius and negative pi over 6. So I'm going to go down pi over 6. So down pi over 6 would be this line right here. And then I'm going to go out 3 from the center. So 1, 2, 3. So that would be my point, 3, negative pi over 6. So negative just means we're going to be going down to start. Positive angle means we'd be going up from 0 to start. All right, another color, sure, blue. All right, so our r is negative 2. Well, that's different. And our theta is 5 pi over 4. So we're going to start from 0 and go around to where 5 pi over 4 would be, which is past pi over 4, and all the way down to this line right here, 5 pi over 4. And then instead of going out 2, we're going to go backwards 2. So if we go backwards, that's actually pi over 4. All right, so that makes a straight line there. So we went to 5 pi over 4, and then instead of going out 2, we're going to go backwards 2, which is 2 in the opposite direction, which puts us right there. So we're at negative 2, 5 pi over 4. All right, so we can do negative as well with angles and with r's. I know, it's a little weird, but it works. All right, the last one, 1 and 3 pi. All right, well, if I start from 0, I go 1 pi, gets me to here. 2 pi gets me back to 0. 3 pi gets me back to here. So you can go around the circle multiple times before you get where you want to go. That's fine. All right, so that would be going out 1. So that would be the point 1, 3 pi. All right, so that's how we can graph in polar for points. All right, so I guess the first question to come up is, so how do we go back and forth between polar and rectangular? So here is down here is a point in polar. It's r theta. So we've gone up an angle of theta and out a distance of r. All right, we can go back down to the x-axis and make a triangle with that. And how far over you go would be your x-coordinate. And how far up you go would be your y-coordinate. So the way we can get these two sides is just basic trig operations. We can set up a little ratio and say, well, let's see, sine of theta equals opposite over hypotenuse. So it would be y over r. And if we just multiply the r up over here, we get r sine of theta equals y. All right, and that's how we get y equals r sine of theta. And we can do the same thing with cosine. We can set up the little ratio with cosine. And we could say cosine of theta equals x over r, and then just multiply up the r, and we get r cosine of theta equals x. All right, and that's how we get x equals r cosine of theta. All right, so if we want to switch from polar, and we have theta and r to x and y, we just plug into r cosine of theta, r sine of theta, that gets us our x and y. All right, if we want to go backwards, because we like polar so much, we just want to go into polar. Polar is easier for some things. All right, we can just say, well, y over x is tangent of theta. Right? And we can do like theta is the arctan of y over x to go back to theta. And we can just do the Pythagorean theorem to get r. So r squared equals x squared plus y squared. So r would equal the square root of x squared plus y squared. All right, so here's some polar coordinates, right? We've got an r and a theta, and we want to go back to x and y. Well, x would be 2 times the cosine of theta, so 2 cosine of pi, and y would be 2 times the sine of theta, 2 sine of pi. All right, so if you remember, cosine starts high, goes down, goes back up, so it's at -1 there. So this is 2 times -1, which is -2. And let's see, sine starts at 0, goes up, comes back down. So sine of pi is 0, so we get 2 times 0, which is 0. So we get the point -2, 0. And if we were to graph both of those, it should end up in the same spot. -2 up 0, there we go. And if we go around pi and then go out 2 coordinates, that would also put us right there. All right, so that does work. All right, you can always graph them both to check. The next one, we've got √3 for our r, and theta is pi over 6. So x is √3 times the cosine of pi over 6. And y is √3 times the sine of pi over 6. By the way, when I learned this, I always go back to thinking about the triangle and just looking at the triangle, but it is alphabetical order. Like the letter x comes before y, c comes before s. So x goes with cosine, y goes with sine. So you can try and remember it that way if that helps. Let's see, cosine of pi over 6. We might need to sketch pi over 6. So that's 30 degrees, that's 60 degrees, so that's 1, 2, square root of 3. So this would be √3 over 2 times √3, which is 3 over 2. And then sine would be 1 over 2. So this would be √3 times 1 over 2, which gives us √3 over 2. So then our point would be 3/2 square root of 3 over 2. So it might be easier actually to graph this guy than it is to graph that guy. But yeah, I don't know, probably both about the same. So we'd go over 3/2. There's 1, there's 2, so 3/2 would be right there. Then up √3 over 2, which would be somewhere around, I don't know, here maybe. Which would be the same thing as going at an angle of pi over 6 and then going out a certain amount. All right, if we have rectangular and we want to go back to polar, we use the bottom 2 sets of guys here. Let's go back to another color here. So here's my x and my y. So that means I would have tangent of theta equals y over x. So 1 over -1, or in other words, -1. So I'm getting that. We're getting that theta equals the arc tan of -1. So we want to know which angle has a tangent of -1. Well, let's see. There's a couple ways we can do this. We can either plot the point and just kind of think about it. Well, it's back 1 and up 1 up there. So it would be going, it's definitely in the second quadrant. And 1 and 1 is going to give us pi over 4 here. So this would be 3 pi over 4. And then to get r, well, r squared is equal to -1 squared plus 1 squared. So r is equal to the square root of that, which would just be the square root of 2. So we get that our point would be r, which is the square root of 2, theta, 3 pi over 4, like that. And haven't used red yet, so that's one more, x and y. So that means, sometimes it is easier just to graph the points and think about what angle would I go to get there. But if I tried to set this up, I would say tangent of theta is 2 over 0. Undefined. All right, so where's tangent undefined? Well, one way to figure out that is go over 0 up 2. Well, now it's real easy. My angle is just going out to there. It's just pi over 2. All right, and then my radius would be the square root of 0 squared plus 2 squared is, well, that's going to be 4 under there. Square root of 4 is just the 2. So I get r is 2. My theta is pi over 2. And there we go. All right, so that's how we convert back and forth between our points. All right, graphing in polar. All right, so the first one, r equals 2. I don't see any theta here at all. So that means for any value of theta, my r is still going to be 2. So if I go out for, say, 0 as a value of theta, I get 2. If I go out for pi over 6, I'm still at 2. If I go out for pi over 3, I'm still at 2. And pi over 2, I'm still at 2. In fact, it's just going to be the circle that goes around here. Tough to trace with this software. At 2. So this is r equals 2. All right, next one. Theta equals pi over 3. Well, there's no r here. So one point would be, 0 pi over 3. Another one would be 1 pi over 3, and then 2 pi over 3. So we go out to where pi over 3 is, which is this guy right here, and I can go out any radius I want. So this makes a straight line. I can also go negative. Negative would be, where is it? 4 pi over 3. There we go. It's tough to draw straight lines on here. All right, so this would just keep going forever this way. This would just keep going forever this way. And this would be theta equals pi over 3. R equals secant of theta. All right, so now we might have to start finding some points. And if you remember, secant is 1 over cosine of theta. All right, so one way to do this would just be to plug in a bunch of theta values and see what we get for r. So like, in other words, if we have theta is 0, what's r going to be? Well, cosine of 0 is 1, we get 1. So if I go over 0, I should be out at 1. All right, next, if my theta value is, say, I don't know, pi over 6. That's not a tough one to draw. Pi over 6, that's a 30-degree angle. That looks like this. All right, so this would be 1, 2, square root of 3. Cosine would be root 3 over 2. So secant would be 2 over the square root of 3, which is a little bit more than 1. All right, so if I go up to pi over 6, I'm going out a little bit more than 1. Say maybe right there. If I try another one, say pi over 4. So there'd be 1 square root of 2. So secant would just be the square root of 2, which is a little bit more than this guy. All right, so if I go to pi over 4, I go out just a little bit farther. All right, let's try another one, pi over 3. All right, so if I do pi over 3, it's a bad drawing, but oh well, it'll work. Root 3, 2, 1. I'm going to get my secant is 2 over 1, so I'm getting 2. So if I go to pi over 3, I'm going to go out 2. All right, and you can see that these points are starting to line up. In fact, this just makes a line that just goes, well, straight. Straight's hard. Wish I had a ruler here. Straight line, straight up and down. So this is r equals secant of theta. All right, neat, huh? All right, we can get more complicated. All right, so we can graph stuff like r equals 2 cosine of 3 theta. So one way to graph this would be to just graph this in rectangular coordinates. And let's see, my amplitude is 2, so I'm going to go up and down 2. I'm at a cosine, so I start high, and then I follow this pattern, go down, then go back up, and then I would just keep doing this pattern over and over and over again. So ordinarily this would be at 2 pi, but we've got a 3 in there, so that means this would be at 2 pi divided by 3. And this would be at pi, but we've got a 3 in there, so this would be pi divided by 3. And this would be pi over 2 divided by 3, which is pi over 6. And this would be 3 pi over 2 divided by 3, so this would just be pi over 2. All right, and then it would continue following this same pattern. So if I try and just graph this now, let's see, at 0, I'm out at 2. At pi over 6, I'm back at 0. So at pi over 6, I'm back down to here. So presumably, I went somewhere from here down to there, and I got progressively smaller, so it looked like I probably would do that. All right, now by pi over 3, I'm at negative 2. So pi over 3 is right here, and I'm going to go backwards 2 down to there. So presumably, it would probably follow around like that. And then back by the time we hit pi over 2, which is this guy, I'm back to 0. So I'm heading back to 0 here, probably like that. And then by 2 pi over 3, I'm back up at 1, or back up at 2. So 2 pi over 3, which is right here, I'm back out to 2, which would be up there. So I would probably follow this curve around like that. And then we can just kind of picture what's going to keep coming on. So it's going to come back down again, back to the -2, then back up to +2. So it's going to go back down to 0. Right? And that would be right there. And then in another pi, which divided by 3, so that would have been 3 pi over 3, so that would be at pi. So at pi, instead of being up at 2, we're down at -2, we're back to where we started. All right, so we're making these petals. All right, and then this follows around here, and that follows around there, and that follows around there, and we would just keep doing this over and over and over again. We keep going through this origin. I miss it sometimes, but yeah, we're going through the origin every time. We can also graph this on the calculator. So real quick, this is the last thing here. If we pull up the calculator on y, oh, well, first we need to change the mode. So we got to go to mode, and we've got to change it to polar. So I've already done that. So polar is right there. So we put it on polar, press enter, and we can leave this, second quit. Then we go to y equals, and it's no longer y equals, it's r equals. And we can just type in our equation, 2 cosine of theta. So we I'll just type it in again. 2 cosine of 3. And then we use this x for our variable. See, it says x, t, theta, n. So if we're working with rectangular, it's x. If we're working with parametric, it's t. If we're working with polar, it's automatically theta. All right, and then if we graph, I think I've done zoom trig. We're working with trig functions here, so zoom 7 trig. There it is. All right, it's a nice little small version of it, but that's that little guy. There's my rose with 3 petals. All right, so each of these is called a petal. And it does make a flower type thing, which we often just call a rose. All right, so that's how we graph in polar and a little bit of intro to polar. That's it for this one. Next one, we'll go over some more calculus type stuff.